All right, well, I guess go to the first slide, second slide.
Okay, now it goes. Okay, you see now. Okay, I don't think I should comment it. You can write. It's my biography, quasi, and then the next figure, please. There are my books and my work. Yes. So the next figure, please. So now it is a content. I tried to describe all possibly short. It is the content, and now we will go step by step. First, the introduction. Okay, thank you. Introduction. Why we need a digital twin? What is a digital twin? There are two kinds of twins. First, for industrial production, and second, for study and education. The difference is, by industrial production, the digital twin should control all production of some ordered product. And by study and education, we try to exchange a real device by some digital twins. So the next figure, please. Okay, thank you. It is only a figure shows how conventional production will be done. Namely, it will be sequential production without considering the features of the product. That means one station after another station. And the digital twin means that a client will order a product, and in the order will be given already the sequence of operations. And practically the digital twin controls the production. So the next figure shows the difference. Now you see next figure, please. Yes, you see now the difference. On the left, we have the conventional production, one station after another. And on the right, we see that the station will be changed, will be chosen according to digital twin. As far to industrial production, it is not our topic. That's why that's enough for industrial production. The next figure, please. So now we are by twins for education. Why we need a digital twins? Downstep we see that there are the following possibilities to use the laboratories by the study or education. Namely, the pilot devices are known real world, or real or only simulations is called here virtual world, or remote control from another university, and finally the digital twins. So the main purpose of digital twins is practically to use not the expensive devices. Now it is only, I think it is clearly known what is pilot plant and what is hardware model. It's only a figure to show it. So we go next figure. Now we want to explain what means virtual world. Now we see here some example of simulation. On the left, we see the simulation on some level control. On the right, it is the MATLAB model. It is all okay. The model describes the level control, but the disadvantage is that the students don't see the real device. They have no feeling that they are working with a real device. So it was so-called virtual world. The next step, the next figure is web laboratories. In my paper, I described the web laboratory and our cooperation with University of Chattanooga. And here is only one example. We see the real device is in the University of Tennessee, Chattanooga, and the students receive the data, the measured data, then they use the model, and from the model they get the step response. So that means the students are, for example, in Darmstadt in Germany, and we have the device far from us, and we can use it. Of course, it is good solution, but the next solution is, the next figure, please. The next solution is a digital twin. Before we go to the digital twins, some explanation, how many kinds of simulations there are. There are so-called meal, zeal, and peel. This figure is a little complicated, but it is explained on the following figures. So if we go to the following figure, the next figure, now we see what are these three options. The first option, modeling the loop, means that all elements of the loop are simulated with the same software, for example, MATLAB. By software in the loop, we generate a code from controller, but the plant is software as a MATLAB. And both code and software, both are installed in the same PC or in the same controller. And the last option is processor in the loop. In this case, we have a code of controller is implemented on another host, for example, on a microcontroller board, and the plant is in our PC, namely in the MATLAB. This option is very interesting and very useful because we can use practically a kind of real controller with a model of the plant. So there are the options. And now the next figure. Now here is shown the stages of digital twins. I think it is nothing exceptional. We have first we do simulation, then we visualize, and interesting is that we should then finally to synchronize. And this stage, is more complicated are all first two, because we should so synchronize that the processes here in the real device and the processes in the digital twin, they should be parallel, be synchron. They are the stages. The next point, the next figure. So now I want to show some examples, and there are three examples. The first example is our first try. Namely, it is not seen not as a real device. You see on the left we have a real device, on the right we have the digital twin. And of course, we see immediately that the visualization of the digital twin differs from the real plant. It is, of course, a disadvantage, and that by the next simulation, we improved it. So the next figure. Meanwhile, we have here the links. I don't think that I should start it now because it takes time. But later, if you have interest, you can start and see how they work. This example is a mechatronical device, and interesting is that by this example, the students first designed the device with CID Siemens, and then build the device, and finally they simulate it and get the digital twin. So that means by this example, we have completed all stages from designing the device and building the digital twin. I don't think I have no. Okay, I have a link to the video, and I can only say that this device is now used by one company, BASF. It's a very great company in Germany. So the next figure, please. And this example is a very perfect example. If you will find the time and look this link, then you will really don't see the difference between the both visualization, both videos, on the left and on the right. And only, I don't know if you can really recognize what is the real device and what is the simulation. So I will not tell you what is, because the main purpose of the digital twin is here to see, namely that you see no difference. Both will be used exactly as the same. So now I have shown you the three examples, and now the next step, next figure, please. Now it is very interesting to calculate, is this all efforts we will done by to build digital twins, is it effective or not? Now, of course, to begin, we thought that is very effective, but when we calculated it, you see that the license costs are very high, and that's why the summary, the whole advantage is only 26% for so for one laboratory of the 15 working places. This example is as a mechatronical device. So it is generally my presentation. Now we have only to see the summary. And by summary, I tried to show the benefits and the disadvantages of digital twins. The benefits are the easier preparation for training, then the unlimited number of people can work with it, and then the digital twin can be adaptive to many, many different courses. For example, in our case, they are automation, PLC programming, and so on. There are the main benefits. Of course, this 26% of costs also, but we have also disadvantages. The next figure, please. The disadvantages are that the design is not so easy, but however, it only one times. Then the CID licenses are very expensive, and the other points are practically the difficulties to implement real control for example, MATLAB. But the general conclusion of all this is shown on the next figure, namely that the digital twins are, please, the next figure. The digital twins are very important for industry productions and for university studies, and that with these twins we can use the laboratories easier and more comfortable than in classical laboratory rooms. So thank you for attention. Excuse me, please, the difficulties by the start, but thank you that you helped me to show the presentation. If you have questions, I will try to answer. If not, then send me please by this link. Thank you very much.
Thank you, Dr. Jakar.